Good afternoon, everybody. My name is Krista. I'm your host today for this track for the Joint Information Warfare. Today we have our first presenters from Technica Corporation, Doug and John. So we're going to go ahead and get started today. And then after this presentation, I will come back on screen. Go ahead, Doug and John.
Great. Thank you, Krista. And thank you, everyone, for joining. Today's topic that we want to address predominantly is AIOPS, Artificial Intelligence for Operations. But before we do that, I'm going to introduce a little bit about Technica, a little bit broader, introduce a little bit of our broader capability set, and then I'll introduce John to talk specifically about the AIOPS component of the presentation today. Okay, so Technica has been around for a while. We're just celebrated our 30th anniversary last year. Technica is a company that supports the defense of the nation's critical networks and systems through application of advanced solutions for cyber operations that improve the speed and effectiveness of cyber missions. And I'll talk a little more about what that means. We are a mid-tier systems integrator, about 250 employees, predominantly working in the DoD and law enforcement space of the federal government. And we operate under 3 lines of business: our traditional systems integration, value-added reseller, and research and development. All those areas really focus on networks, network operations, data and data analytics, and cyber operations. So we are members of, or contract holders, prime contract holders for both the Jake Drade and TNE BPAs, and we're also on the Booz Allen Hamilton team for the Joint Warfighter. As I discussed, we have several capabilities, mostly focused around cyber operations, cyber warfare, everything that we do from networks into our research and development and artificial intelligence, et cetera. And in our applications development is focused around supporting DoD law enforcement in the cyber operations mission. Want to talk a little bit about some of the relevant research that we've done in the past and doing now prior to getting into some of the AIOPS discussion. So things we've done in the past, we've done research into graph analytics using graph neural networks to help make sense of complex data sets, and also focused a lot in the past on AI and ML optimization for low swap devices. So complex compute for AI at the edge, et cetera. Those things, when we turn the focus of the company purely in the cyber, those things really help to feed into the things you see on the right-hand side. Explainable AI for cyber threat hunting, applying the graph neural networks to cyber threat hunt, and natural language processing for log analytics, or log analysis and log analytics. Threat hunt, we're working on threat hunt acceleration through the application of DPUs. DPU is a new class of processor. It's a data processing unit, if you've not heard of it. So you've got CPUs, GPUs, and now DPUs are being introduced. And the DPUs really focus specifically on being able to do high volume, high speed data ingest, storage, access, et cetera, offloading that work from the CPUs to be able to make those more effective and efficient. It's particularly useful in defensive cyber operations threat hunt, where you're looking at real-time network data. And then, of course, AIOPS and the AIOPS for cyber operations that JR will talk a little bit more about later. So first, from the systems integration side, Technica focuses on defensive cyber integration. And by way of example, Technica is the prime contractor for Air Force weapon system called the CVA Hunters, Continuous Vulnerability Assessment Hunter. We do everything in that from the requirements gathering, development of the core software, integration of the software sensors, test and evaluation of new sensors, new hardware equipment, et cetera, and to deployment of the software onto hardware, all using Agile DevSecOps, in a CI/CD pipeline environment. This is the primary threat hunt weapon system for the Air Force. It comes in 3 different variants: a mobile variant, a deployable variant, which is called the Deployable Interceptor Platform, or the DIP for short, which is probably the most used piece of this. It's used by the cyber protection teams for the Air Force, some of the special forces, and a little bit of the Navy. And then also a garrison data platform, which is used by the mission defense teams for their mission out in the Air Force, primarily Air Force use. We talked a little bit about this earlier on, the graph neural networks for the cyber threat hunt. So basically, we've kind of created a end-to-end system of composite machine learning models that implement a raw application programming interface and capture network traffic files to output series of classification labels corresponding to the nature of flows containing these files. So in our outputs, we reveal only activity identified in malicious flows from which network attacks have been identified, and then these attacks are automatically applied to a MITRE ATT&CK framework. This was a challenge problem issued by the U.S. Cyber Command, and so we took the opportunity to take a unique approach, apply the graph neural networks to this problem, and we had recently taken first place in that Cybercom challenge that was hosted by the MISI Dreamport. It's called the Rossum's Universal Robots. And if anybody has questions or interest in learning more about that, we'd be happy to do so, to talk with you about it. Which kind of brings us into the Technica's Intelligent Data Path for Analytics, which is really kind of the front end and the first step into the to implementing a successful AI operation. So with that, I'll introduce our senior architect, John Robinson, who will kind of walk us through our AIOPS solution set.
Okay, thanks, Doug. And thank you for your time today. So one of the areas that we're focusing some of our R&D activities around have to do with an intelligent data path for analytics. One of the areas that are misunderstood or not really elevated in discussions is the acquisition of the data when you're doing analytics. So there's been too much focus on the analytics engines and the data repositories for collecting, aggregating, and storing all that data, normalizing all of the data, tagging it, and then applying the analytics against it, and not so much on acquiring that data from all the varied data sources. So you don't want your analytics engine having to touch or interface directly with all those downstream sources. You want to have something that's more flexible, scalable, and intelligent, that abstracts that data so that the analytics engine has a consistent, predictable data stream coming into it, and not have to worry about, not have that burden of developing the interfaces. There's a lot of different types of data interfaces, some more mature and current, and then there's a ton of legacy data interfaces that are pretty obscure, that we don't want the analytics engine vendor or integrator have to worry about those. So we've been putting a lot of focus on this space to accelerate the data integration pipeline. And also the other area that we're focusing on is supporting the tactical edge, tactical environments where there's disconnected or constrained networking environments, we want to be able to support those environments without disrupting the data flow, so that there is data available to do the forensics or the analysis when the connectivity is available. Next slide. So with that in mind, we're taking the pipeline, and we're taking the analytics that Doug touched on, and applying those to cyber operations. So employing analytics techniques to cyber operations. So cyber operations is no different than any other big data analytics problem or challenge. There are many data sources, data repositories in the cyber operations world, and cyber operations, including the day-to-day operations administration of cyber services, as well as the cybersecurity continuous monitoring, risk and analysis and assessment. And we have gone to engagements where it's a small ecosystem or enclave in comparison to others that we've gone to, and they have upwards of 100 cyber operation tools. And all of them have their own independent data repositories, their own way of looking at the data, managing it, and having operators or humans involved with managing all those data sources is problematic. It's a challenge. They can't keep up. So we want to apply the analytics to this large volume and pool of data. So we can do anomaly detection, where we alert triggers automatically against anomalous activity. We can do dynamic thresholding as opposed to static thresholding. So dynamic thresholding, where we're taking into account seasonality or cyclicity of behavior. So if things are happening every day, the same type of activities happening every Monday of every quarter because of the way they do the operations, and it may be exceeding a static threshold, but it's normal behavior. Well, with dynamic thresholding algorithms, we can identify that as a normal behavior and not send out false alerts and burden the operators with having to chase it down. Do a lot of we apply event clustering to suppress noise, so that we can actually identify the right root cause and get the incident, the event, to the right people for remediation. There's a lot of intelligent automation built into all this analytics for AIOPS. The automation basically are playbooks based on decades of experience in operating IT systems. And so that we can leverage that knowledge base and start taking a look at automating the remediation. If it's something that's rote, continuously happens, we can actually have the machine identify that and remediate it for quicker resolution, so that the end users are up and operating as quick as possible. We could also just stick the human in the middle and make sure that we have some human verifying before the actual technology actually executes the remediation actions. So this basically decreases the MTTR and makes the services more stable. And then there's predictive analytics that we apply. Big use case around this is capacity planning, trying to identify when capacity may expire, may exceed the volume coming in, the demand, so we can actually predict when we need to add more capacity. So this makes the operation life cycle a little bit more efficient, so we're not having to buy a whole bunch of capacity up front and have it sit there waiting for the demand to exercise it. So we can actually do it a little bit more on time, just in time. Next slide. So our approach to autonomous operations with AIOPS is anchored by AIOPS technology engine. It's COTS-based, it's domain agnostic and full stack. It's very important. There are a lot of AIOPS technology solutions out there. that are domain focused. They're focused around incident management, making that a little bit more efficient, application performance monitoring, things like that. They're very domain focused, log-based analytics. We wanted to make sure that we had the full stack and that we can cover the entire spectrum of cyber services and operations. So it's a full stack domain agnostic technology in the background. Does the root cause analysis, anomaly detection, proactive problem management, automation, and full context of the environment. So with that, and as I said previously, with the data pipeline, we integrate our Technica developed data hub. It's an API-centric data hub, very scalable, durable, has technology and features to support the DDIL environments, and support a large array of data sources. And we can apply inline, in-flight data transformation, data normalization. We can actually add in some analytics to the data pipeline, so we can do some streaming analytics, basically to make that data pipeline more efficient for the analytics engine on the back end. So that analytics engine is only worried about one interface, and that's our interface, and we make all the downstream data sources transparent. And the other aspect of the data hub is it's open, it's all open source, open technology. So we recognize that it's going to be part of a larger enterprise ecosystem, so it's pluggable into some unified enterprise data fabric that anybody in the enterprise can access the results of the analytics. So we also don't intend to do a rip and replace with our approach. We actually do we actually plan and intend to supplement and enhance all the existing management capabilities that are already on the ground, and then make the alert management of alerts a lot more effective and efficient, so that the right people are looking at the right problems at the right time to remediate issues faster. So we want to make the operators and analysts more effective, and so they can focus on more complex problems or more innovation, and not worry about the mundane day-to-day operations that a machine could actually automate. And this whole concept here is try to make it more effective to operate missions for our DoD clients by advancing cyber operations to a more proactive and autonomous environment. And I'll end it there. You're on mute, Doug.
There we go. With about a minute left, or a minute and a half left right now, I'll reiterate some of what JR said at the end and why we thought this was particularly applicable to a Navy audience, and conversations that we've had with the Navy, and our understanding is that they are challenged in the network environment, particularly shipboard, with limited number and limited skill sets of network managers. So as the Navy's become more, the Navy ships become more and more networked, the crew still has a limit on the size it could take. So they don't have the luxury of having tens and multiple shifts and of high level network engineers. So the AI operations allows, as JR said, some intelligent decision making. Right, it allows automation for some of the more mundane things. It allows for automated identification of things that should be checked out by an operator to make best, more optimal use of the operator's time, so that you can kind of do more with less, do a better job of managing and monitoring the network with fewer people and often lesser skilled people. So those are some of the conversations we've been having with the Navy, and where this technology and this concept really can apply.
All right, thank you.
So Krista, that about wraps it up. Thank you very much, everyone.
Thank you so much for your presentation today, Doug and John. We're going to take a 5-minute break, and then we will start with our session 2 in 5 minutes. Thank you, guys.
Thank you.
Thank you.